Screaming whines of infernal violence alternate with periods of dead calm as one nears the surface of Uranus, according to a new analysis of the gas giant. The turbulent weather patterns on gaseous planets has long been known. Think of the giant storm raging on Jupiter that makes up its famous eye. But little had been known about life on the surface of distant Uranus. A new analysis of data taken by the spacecraft Voyager 2 during a flyby in 1989 reveals the dynamic winds that lie on the surface of the planet, beneath an atmosphere thick enough to swallow the entire Earth. And on the planet itself, things are surprisingly calm. Our analyses show that the dynamics are confined to a thin weather layer no more than about 680 miles deep, said William Hubbard, a planetary scientist with the University of Arizona's Lunar and Planetary Laboratory. This number is an upper limit, so in reality, it is possible that the atmosphere quiets down even shallower than that. Without a means to probe the atmosphere of gas giants directly, the researchers had to rely on indirect measurements to gather clues about weather patterns on the two planets. For Neptune and Uranus, the only spacecraft data we have were taken with Voyager 2's equipment more than 20 years ago, and we won't be able to get anything that lives up to today's standards anytime soon, explained Hubbard, whose research focuses on studies of the structure and evolution of Jupiter, Saturn and extrasolar giant planets. Instead, the team used deep circulation theories to predict what the gravitational fields of Neptune and Uranus should look like. And unlike the turbulent jet streams there, Hubbard said the winds are much more subtle on Jupiter and Saturn. We'll learn more when NASA's Juno spaceship, currently en route to Jupiter, arrives at the big planet, he said. When we start getting detailed data from Juno, we are going to use those methods to apply to what we see on Jupiter and Saturn, he said. We want to see how deep these weather phenomena go on those planets. Hubbard explained that researchers believe the atmospheric disturbances are more numerous on Jupiter and Saturn but less strong compared to Uranus and Neptune, for reasons that may have to do with the planets' different compositions and their angles between the magnetic fields and rotational axis. In the case of Earth, our atmosphere is very thin and almost negligible from the point of view of gravity, Hubbard explained. In the case of giant gas planets, we are talking about deep, hydrogen-dominated atmospheres that are much denser, more like an ocean than an atmosphere.